Now, you probably know these as box and whisker plots. We just refer to them as box plots. But more importantly, we're going to actually be doing what are known as modified box plots, or box and whisker plots, in AP Stat. So we have this thing about modified. And what the difference is, so a box plot is the same. First off, a box plot is a box and whisker plot. Okay, we'll talk about that. But we also need to draw and understand and be able to read as well as be able to draw. Whenever we are asked to do a box plot, we're always doing modified box plots, and a modified box plot identifies outliers. So today we're going to learn a rule to determine outliers. In our previous courses, or our previous topics, we kind of eyeballed it. We always did like the eyeball test. That data point looks far away from all the rest of the data points. It's likely an outlier. All right, that's what we did before. Well, in today's material, we're going to actually come up with our first rule. There's actually two different rules that we can use, two different ways that we can identify outliers. One uses the median in IQR. One of them uses IQR. One of them uses the standard deviation and mean. We're going to learn the standard deviation and mean in our next unit. Today, this unit, we're just going to focus in on the outliers using the 5-number summary. So a box plot the box plot is a visual / graphical representation of quantitative, where am I today? Quantitative data that uses / shows the 5-number summary along with identifying outliers. Now, there are some disadvantages here. The disadvantages of a box plot are that we cannot see individual responses. So we don't know what the responses are. We will know at least 2 responses at most. You'll know what the maximum response was, and you'll know what the minimum response was. You will know that that was a response, because that's how the min and max are data points. They are a value, always. They're values. However, with the 5-number summary, the median, remember, doesn't technically have to be a data point. If there was an even number if n is even, and you have the middle 2 numbers are like 12 and 14, then the median is 13. And it doesn't mean that 13 was a data value. So we cannot see individual data points, and you cannot, and this is always a big mistake, determine unimodal / bimodal properties. However, it is possible to determine skewed / symmetric still. So you can still answer for shape. So if the question asks for shape and you say unimodal and all you're given is a box plot, right when you say that word unimodal, boom, you've lost credit on the AP exam because you can't determine unimodal or bimodal. However, you can talk about shape in the sense that, oh, this data is going to be skewed, and we'll show you how to do that as we go into practice. Or this data is symmetrical. We'll talk about how to be able to view that and be able to give that response. Okay. Now, I do want to note that box plots can be drawn horizontally or vertically. The graphing calculator is horizontal. The textbook will show vertical. I go horizontal for notes. But the solutions might show vertical. All right, so the solution guides might show vertical, but it's the same thing. All right, it's the same thing. It's just you're drawing it, up and down versus left and right. It's going to be the same thing. Let you have a little time to write this parts down before we get into the actual diagram of what box plots look like.
Mr. Two. The arrow that's pointing to horizontal says I go
with horizontal for notes.
Okay, thank you.
Box plot requirements. / properties. The first and foremost thing, of course, is context. Make sure you identify who and what in your box plot. And because it's a what is a quantitative, that means units. The second thing is a scale. And also noting that it is evenly spaced. The third part is that you have the min, Q1, median, Q3, max, and shown. The fourth piece are outliers, if applicable. And the fifth part is the box and whiskers drawn. So when I'm drawing a box plot, technically I'll state who we're talking about on the top. I'll do a number line. I'll talk about the what with the units. I will number these, and they'll go up by the common numbers every time. Okay. I will identify where the minimum is. I'll identify where Q1 is, the median is, Q3 is. Actually, I want. And where the maximum is. Okay, that's always going to be in my box plot. However, if the max turns out to be an outlier, if the max is an outlier, then I also must show the next highest point. If outlier. So if there's an outlier, the next highest or lowest. Okay, or lowest for that case. So when we draw a box plot, so now when I draw the box plot, I put a whisker, I put a line at everything that's not an outlier. Anything that is not an outlier, and actually I wanted to drop that down just a little bit. Any value that is not an outlier, I draw a line. Not an outlier, not an outlier, not an outlier. Now, since the max is an outlier, I'm not going to draw a line. I'm going to draw a line at the next value that's not an outlier. Okay? Outliers stay as dots. In other words, if it's an outlier, if it's not an outlier, you kind of shouldn't see the dot because the line should be superimposed on top of it. And then I make my whiskers. The whiskers are from the min to the quartiles. Those are the whiskers right through the middle. And the box is using the top and bottoms that show Q1 and Q3. So that's the process of making a box plot once you have identified outliers, of course. The problem comes if there's outliers. Now, looking at this maximum, you can see this maximum is really, really far out there compared to the other points. So it seems like there could be an outlier. If there seems like there could be an outlier, or if I ask you if there's an outlier, you need to check your work, okay? If it's pretty obvious that there's no outliers, you might be able to get away with not checking for outliers, but typically the AP exam still wants you to check for outliers. Even if you know there's not going to be an outlier. All the numbers are really close together. The max and min are not that far away. That they can't be outliers. Then we don't check for outliers. Or we don't technically need to. That's basically what we want to do. And there's most of the times where you're going to be given the 5-number summary. So either A, you'll be given all of the data, or B, you'll be given the 5-number summary. And I believe for your homework, I give you the 5-number summary. So it shows you what the min, the max, the median, and all those are. So now comes the big picture, the big question. What happens if there's outliers? Okay. So this is the main part of our lesson that should be new for everybody, or relatively new for everybody. Identifying outliers. So identifying outliers it should probably, like this box plot part, besides the outlier, is the same type of things that you probably did in middle school, the same type of things you did in your lead up for the MCAS, A box plot is a box plot. I mean, of course, we make sure that we have some context. We state who we're talking about, AP Stat students, and what we're talking about, heights and the units in inches. We make sure that we include that. But overall, a box plot is a box plot in AP Stats versus middle school and elementary school. Okay. The big difference, though, is that outlier aspect, because it's a modified. And so how do we identify outliers? So the definition for an outlier is defined as any point more than 1.5 IQRs beyond the quartiles. Okay? 1.5 IQRs beyond the quartiles, which means more than Q3 plus 1.5 times the IQR, or less than Q1 minus 1.5 times the IQR. Q3 is right here. So the way we measure outliers is based on the IQR. I told you the IQR is a measure of spread. So here's the IQR. The distance from the IQR is here. This is like a measuring stick for outliers. If I were to make those over here, I can see that in this max, I was trying to exaggerate, but maybe I didn't exaggerate enough. This maximum is about, just a little bit under 2 of these lengths. This is the length of the IQR. So here's one length of the IQR. Let's say that matches. And here's another one right there. Let's say that kind of matches. I know it's not perfect, but it's kind of going above that. If it is more than 1.5 of the box's length, IQR is the box length. This distance right here, and I kind of didn't show this, but it should be known that this distance between here and here is the IQR. You don't have to actually label that in your box plot, but we need to understand that when I say, well, what's the IQR? Well, the IQR is the length of the box, the Q3 minus Q1. Because of this, we have a formula for doing it. We call these the fences for outliers. I like to think of it like Jurassic Park. If you're inside the fences, you're good. You're not an outlier. So it's all the omnivores and so forth. But if you're outside the fences, that's where you're trouble. Those are the carnivores. So the fences, you got to think about the fences, and we're going to draw in our imaginary fences. We'll use like little dashed lines to kind of show where these fences are. And if your whisker would have gone, or if your max or min, or any points that are outside those fences are going to be outliers. And you can have multiple outliers. You can have more than one outlier. You can have multiple outliers above. You can have multiple outliers below. So the fences for the outliers, which we refer to as the upper fence, and lower fence. If you are more upper, bigger, higher than the upper fence, you're an outlier. If you are more lower, less than the lower fence, then you're an outlier. This formula is not given on the AP exam, so this formula is something that you probably need to have readily available to you or put towards your memory. 1.5 IQRs. That outlier, 1.5 IQRs. Outlier, 1.5 IQRs. Of course, that's your first step. So the lower fence, and here's your first formula. The lower fence is equal to Q1 minus 1.5 Q3 minus Q1. Or sorry, first off, IQ, I like to write it IQR equals Q3 minus Q1. And so it's 1.5 IQR. I know I'm rewriting just what I wrote up there on top. And the upper fence is Q3 plus 1.5 IQR. Something to note. The textbook will use asterisks for extreme outliers, which are more than 3 IQRs away from quartiles. This is not required. So you don't have to worry about the asterisks. If we have an extreme outlier, like whoa, we call that like maybe there's most likely there has to be something wrong typically with an extreme outlier, or there's going to probably be a bigger explanation for extreme outliers. You don't have to worry about extreme outliers though. We just going to use the rule 1.5 IQRs. Question? Yes.
If something is far away from the quartiles, doesn't that affect the standard deviation?
Correct. That's why when there's something that's far away, that's why we're basing everything on the IQR and the 5-number summary. So in today's topics, in today's thing, we do not talk about anything with mean and standard deviation. There's no mean and standard deviation in play here because it will. Okay. Box plots are great. Box plots are technically should always be are using the 5-number summary, but box plots are our best ones to help us compare distributions, which is our topic that we'll be moving towards. Our final topic is how do we compare. But exactly, there is a way to utilize the standard deviation, and that's going to happen next unit. There is a way to identify outliers using the standard deviation in the mean. That's our second rule. We do not have to worry about that at all right now. Right now, we're ignoring standard deviation and mean on tonight's homework at least. And you're only focusing on the 5-number summary. So when you draw a box plot, you're going to draw your box plot. You're going to have your who, your what, your numbers, all the values. And then you're going to you're going to draw the dots for your mins. Your 5-number ones, right? And then what you're going to do is you're going to find your lower and upper fences. So you might draw and you might find out your lower fence is right here. This is where the lower fence is. And then you find out that here is your upper fence. So are there any low outliers based on what I've drawn right here? Are there any low outliers?
No.
No, because the minimum is bigger than the lower fence. Are there any high outliers?
Yes.
Yes, because this is outside the fence. And when there's an outlier, you need to also verbally state if it's a high outlier or if it's a low outlier. So just make sure you say that. So because there's an outside outlier, that means that you need to go to the next highest point. Well, if the next highest point is here, is that an outlier? If this was the next highest?
Yeah.
It's still an outlier. So that means we need to go to the next highest. The next highest one lands right here. Is that an outlier? Is that point an outlier? The next highest.
I think it's not.
It is not. And so once you've found all of them and then there's no longer an outlier, then we go boop, 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 boop. Draw in the middle, box, box. Boom, draw my box plot. Now, I want to note something in here. I want to talk about. I want to talk about here. Sometimes data not given. As such, pick a point near inside fence that is reasonable to make box plot. So in other words, if you have the data and you can talk about it, yeah, we're about to do an example, and that's what we're going to finish up. If you have the data, then you'll know what the next highest values are. But sometimes you don't have the data. And as such, you know that that max is an outlier. You know that this max is an outlier, but you don't know. All you know is the 5 numbers. All I gave you was the 5-number summary. And because of that, you don't know what the next highest point is. So what you should just do is you pick a point inside the fence, probably close to the fence, and you make your whisker stop there because you don't know the data. Okay. Sometimes in your home, you'll see sometimes you'll be given like a histogram. You'll be given a data in a histogram. So you might notice that there's 2 values on the outside because the histogram went to 2 values, and then the next one goes like right on the fence. Okay, if it's right on the fence, then you have to you can say, well, it could have been an outlier, or I'm just going to draw 1 right there inside there. Let's do an example. All right, let's do an example. We're going to talk about the heights of 28 AP Stat students. This was my data from last year. And here's my summary statistics. The min was 56 inches. Q1 was 61 inches. The median, and this is given, or if I found the data and I found the 5-number summary, the median was 64 inches. Q3 was 66 inches. And the maximum height was 74 inches. So here is my data. I'm going to make a box plot. That's my assignment here. Make a box plot. Okay? So, what should I start off by doing?
Should you label the sides?
Yeah, so let's make a number line and label. So let's start off by making. I like to draw a line first. All right, draw a line. I'm not gonna label. I'm not gonna label it right now, but I'm gonna say who. So I'm talking about 28 AP Stat students, and I'm gonna be talking about heights in inches. Okay, so that's my context. I want my context in my problem. Is everybody okay with that? Next thing, what do I do next?
Label the number line.
Good. Where should I start by? Where should I start?
Like, I mean, if it's gonna be like 50s or
Yeah. Well, yeah. What's my? Okay. Here's my first marking. What is that number going to be?
50, 55.
55. You can even go 56 as long as it's something. You can even start at 56. Okay. If you want to start at 55, you're good. If you want to start at 50, you're good. Okay. And we're going to make our markings. Try to make them evenly spaced. What should I go by? Where do I need to stop? How high do I have to go on my number line?
Is it reasonable to say 80? Is that okay?
Yeah.
Or
Yeah, but what's the requirement? What do I have to go to at least?
75?
74. I have to go to at least 74. You can go lower. It's fine to go lower if you want to. You can go lower. If you want to have 54 in here, that's perfectly fine. You don't have to. The point is you have to have 56 and you have to have 74. All your data must fit inside your number line. All right, what am I going to go by? What's going to be my scale? Like, what am I going to go by? Oh, I just kind of give you the hint here. What am I gonna go by? What's my next number that I'm gonna put on my number line? On the right side. What am I gonna put here?
61?
You probably don't want to jump that much, I would say. Based on this, I would probably go by twos. You could go by ones, but you might have a really long number line. If you go by twos or by fives and you say 61, or while it will be okay, I think everything's going to be a little too squished. I feel you want to at least you want to use some space. You don't want to have to like draw the whole thing across the whole screen, but you want to have some. So I would recommend by twos. D8, 60, 62, 64, 66, 68, 70, 72, 74. If you wanted to go by ones, reasonable. You can go by fours or fives. I just think you're going to have a very hard time visually seeing everything. And you can just look at the distance between the min and the distance is 5 here, 3, and the distance is 2 right there. So since this distance right here is 2, I probably don't want to go by 5s because I'm going to probably be squishing everything inside there since they're all kind of like less than 5. All right, I'm going to now label my points. My minimum, 56. My Q1, 61, goes above where 61 would be. My median, 64. Q3, 66. My maximum, 74. What do I do next?
Should you put a box around them and then label it?
Not yet. That's going to be my final step.
So you find the IQR? No, sorry.
You're on the right track. So remember, context, number line scale, the 5 number summary dots, something else, and then the box and whisker. So what's the step we're missing?
Well, you need to find the fences.
The fences / outliers. It's like a 2-step process. All right, so let's find the fences. So my IQR in this problem, so I'm going to find the fences. I want to find the fences. To find the fences, let me first find the IQR. What is the IQR? Okay, yeah, how'd you get that though? You're correct. I just don't know how you get that.
Q3 subtract Q1. So, yeah, equals to 5. Yeah, 66 subtract 61 equals 5.
5 inches, 5. Okay, so IQR is 5. All right, so lower fence. The lower fence is what? The formula is Q1 minus 1.5 IQR. So what? How? Don't give me the answer. Walk me through it. So Q1 lower fence is what? Just plug in the numbers. Substitute the numbers.
So it would be 61 minus 1.5 times 5 inches.
And we plug that into a calculator. 1.5 times 5 is 7.5. 61 minus 7.5 is 53.5. All right, 53.5 is my lower fence. And I'll draw where my lower fence is. So 53.5 is like right there. In my class last year, so I had some shorties. I had some people who were short. I had some students who were short. But was there anybody unusually short in my class last year?
No.
No, there was no low outliers. There was nobody unusually short. Let's see if there's anybody unusually tall. Upper fence is equal to Q3 plus 1.5 IQR, which is, walk me through it.
$66 plus 1.5 times 5.
So that's 7.5, which gives me 73.5. Oh, just made the... Is there anybody unusually tall?
Yes.
Yes. So there is no low outlier. There is at least one high outlier. Why did I write the word at least one high outlier? Could there be two high outliers? Could there be two outliers, two high outliers?
Yes.
Yeah. I don't remember. I cannot see individual data points. There could be, I had maybe had two individuals who were 74 inches tall. I don't know how many people I had that were 74 inches tall. I know I have at least one person that's 74 inches tall, but I don't know how much the next person's height is. I don't have the data. So I don't have the data. Now, since that's an outlier now. I know it's an outlier. That means I have to go to the next highest point. Well, I don't know what the next highest point is. So what I'm going to, since I don't have the actual data, what I'm going to do is just put a line here because I don't know what the next highest data point is. I just know that the whisker has to end before 73.5. The next tallest person might be 68 inches. I don't know. Okay, so really I could have drawn it there. I could have drawn it here. I don't really know where the next highest person to tall is. But, I'm assuming that it's going to be somewhere over here. If I have the data or if I have more information given to me that I can figure it out, then I would draw it appropriately. Does that make sense?
Yeah.
All right. Now we finish off. Lines, lines, lines. Whisker, whisker, box, complete. Does a box plot breaks the data into 25% into quartiles. So the first part right here, this right here is the, and I'll get into this tomorrow. I was going to get into this. This is the lowest 25%. This is the second lowest 25%. This is the highest 25%. This is the middle 50%. That's what IQR is. This is the lowest 50%. This is the highest 50%. And so it helps break up our data and say, oh, my lowest 25% of students scored below here. 25% of my students scored above here. The middle, which is typically what we'd like to study. I want to make sure that the problems I'm assigning are the problems I'm going to keep assigning. So we're going to do problem 8. All right. And this one is, so here's a histogram and here's a box plot. And I said it's drawn vertically. These questions are more about what do you see? What do you see? What can you see here that you can't see here? What can you see here that you can't see over on the histogram? So problem 8. Next problem is problem 12. Now notice you have the 5-number summary written right in here. All right, the 5-number summary is written right in here. The min, Q1, median, Q3, and the max. Now, what's nice about this one is you also get a visual representation of a histogram to be able to talk about the shape. Now, I'm not gonna have you do part D. I'm gonna just keep it as 12A through C because you can see where the next highest data point is now, but you don't know where exactly it is. It's somewhere between here and here. You don't know exactly where it is. And what happens in this problem that I really like is that the fence cuts right through it. And then over here, I'm just going to have you do 23 up to C, creating the box plots, and 24 up through C, just creating the box plots. So I'm going to post that up into Google Classroom. I'm going to update it on the weekly organizer. That's what I have for you for homework. It is 10:50. You've been a great class today. I will see you tomorrow.